Hello everyone, welcome to part 2 with C++ Tetris. It's time we designed our game. So, Tetris is a grid-based game, which means that the board is composed of tiles. In classic Tetris, the board is 10 tiles wide and 20 tiles long. The player gets to control a random shape called a tetramino. There are 7 different tetraminos in the game. We'll take a closer look at them later on. The player should be able to move the tetramino left and right, also rotate it and drop it. He should also be able to see what the next piece is gonna be, and as a bonus we could give him the ability to hold a piece. If the player doesn't like the current piece, he can put it on hold, and if the inventory is empty, the piece is gonna be stored, and we're gonna give him a new one. If the place is already taken, then the pieces will swap. We should also display the player's score somewhere. If the stack of tetraminos reaches the top, it's game over. We could also add a menu where the player chooses a difficulty, but we'll talk more about menus later on in the series. So the board is the equivalent of the playground for our game. We should probably start by making it. Before we create our board, there's something we need to fix from last episode. We forgot to limit the frames per second for the game. As you can see, the computer's just dishing out as many frames as it can. And unless you're an epic gamer, this is probably a waste of resources. So let's make the game constructor take an extra parameter, an integer for frames per second, change the implementation, and inside we should call set target FPS, and we give it our frame rate. In the main, we fix our call by giving it a frame rate. And now it's properly limited to 60. What? Of course I didn't forget about it. It was the test you. Alright, now for the board. Let's create a header file. Call it board. Create a class. So we're gonna need a way of representing a cell in our board. We're gonna make a private class inside of it, and we'll call it cell. It's gonna have public and private members. The cell is gonna need a boolean to know whether or not it exists. And it's also gonna need a color, which is a class defined by Raylib. So we need to include Raylib. And if we control click on it, it's just a dumb structure with 4 values inside. Nothing too complicated. Let's give it a constructor. Let's make a CPP file for it. Board include board, and let's implement it. In the constructor, we're gonna give a default value to our variables. So b exists, we're gonna give it false, and might as well give it a default color while we're at it. We'll give it ray. Now we'll give it white. Whoops, this is not a class. It's supposed to be C. Okay. Let's give it a public function that lets us set the color. So we assign the color, and we should probably give a different name here. So C receives C input, and if we're gonna give it a color, we might as well make it exist. So we make exist true. Let's give it another function to remove it. And we're just gonna set exists to false. We don't care about the color if it's not even gonna show up. So back to our board. We're gonna use a std vector to hold our cells. We're gonna call it content or cells. Let's include vector. Let's give it width and height constants and a cell size so that we can know how big we should be drawing each of our cells. Let's give it a constructor that takes in the x and y positions on the screen, the width, the height, and the cell size. Now we should also give it variables for the x and y positions on the screen. So we should probably give these a different name, like this. For the implementation, we initialize every single one of our variables. As for our std vector, we should call cells.resize And as for how many cells we want, it's probably going to be width times height. The good thing about calling resize compared to reserve is that it will call the default constructor for each one of the cells. So it's going to call the constructor we defined for our cell, which is pretty good for initializing an empty board. Let's include assert and make sure that the width is above 0, and same thing for the height. And we should probably do the same with the cell size. Now we need a way of filling our board with tiles, so let's go ahead and add a void set cell. We give it an X position and a Y position and a color. And in the implementation, we're supposed to access our cells. And now what? We need to access the cell at the XY position, which is a 2D position, but we only have a one-dimensional array. So how do we do? So we have a one-dimensional board that contains as many cells as our 2D board. And for example, we want to select this cell. So how do we find the corresponding cell in the one-dimensional one? Well, it's simple. We count. So from the beginning, 0, 1, 2, 3, 4, 5, 6, 7. And in our one-dimensional array, 0, 1, 2, 3, 4, 5, 6, 7. So this cell corresponds to this cell in our array. Let's do this mathematically now. The information we have is the X and Y positions and the width and the height of our board. In this case, the X we selected is 1 and the Y is 2. The width of our board is 3 and the height is 1, 2, 3, 4, 5, 5. So to get the number of cells above our cell, all we have to do is multiply the Y by the width. So we go W times Y. And this is going to take care of these tiles. Now all we have left is to know how many cells are at the left side of the one we selected. But we already have that information. It's our X. So all we have to do is add X to it. And this formula is going to let us transform our 2D coordinates into one-dimensional ones. If we apply our case, it's going to be 3 times 2 plus 1, which is 7, which is exactly the same number we found when we eyeballed it. Note that this only works if we start counting X and Y from 0. If you start counting from 1, you're going to have to subtract 1 from the X and 1 from the Y for this to work. So in our program, to access the cell at the X and Y position, all we have to do is go Y times width plus X. And like this, we can go set color, C. We assert that X and Y are bigger or equals to 0, and that X is smaller than width and Y smaller than height. Actually, let's combine them. Like this. Great. Now we need a way to display the content of the board on the screen. So let's make a drawCell function. It's going to take in the X and Y position of the cell, and it's going to be const, because it doesn't modify the variables for the board. So how do we draw a square to the screen? In the Raylib cheat sheet, if we go to the shapes module, we have a whole bunch of functions to draw stuff on the screen. We can draw an individual pixel, draw lines, circles, ellipses, but the one we're looking for is probably a rectangle. We give it the X and Y position, the width and the height, and a color. Pretty straightforward. Let's go draw rectangle. And how are we going to calculate the position? First of all, we've got conflicting names. Here we have X and Y, and in board we also have X and Y, and we're actually going to need both of them. So let's rename this one to screen X and screen Y. Same thing here, and here, and inside. This is better. Okay, so how do we know where to draw our cell on the screen? So our board is going to have an initial position of X and Y, which is going to be the top left of the board. Well, if we think about it, the cell that's at the origin 0, 0 is going to be drawn at the exact same spot the board starts. And if we advance by 1x, we're going to shift by one whole cell size. If we add another x, we're going to shift again. and again and again. And the same goes for the y. Every time we add a y, we shift down by a cell size. Well, we have the initial position of the board, which is screen X and screen Y. It's probably a good idea to start with them. So we can go screen X, screen Y. But this is gonna draw every single cell at the same position. What we should do instead is go plus X times cell size. And this means that every time we go up by 1x, we add a whole cell size to it. We do the same thing for the y. As for the width and the height, it's gonna be cell size and cell size. Yeah, and we're gonna need a way of getting the color. So we're gonna need to access the cells vector. We calculate the index again, like we did the first time. So y times width plus x. And we actually need a way to get the color. So in board.h, inside of the cell class, we're gonna add a getter for color, get color. And it's gonna be const. The implementation is just gonna return C. So here we can just go dot get color, and we can store it inside a temporary color C. And we give it just like this. Let's also add an assertion to check if x and y are within the bounds of the board. So we go assert x is bigger or equal to 0, and x is smaller than width, and y is bigger or equal to 0, and y is smaller than height. Perfect. We also need a function to draw the whole board. So we go void draw, make it constant, and inside we want to loop throughout the whole board. For index of y is equal to 0. As long as index of y is smaller than height, we go plus plus y. And we do the same for x. And now we just need to call draw cell, and we give it the x and the y. Okay, now how about we try to make a board and then draw it. Let's go to main.cpp and make the screen a little bit bigger. The width, we'll leave it at 800. The height, we'll make it 600, not 6000. And this looks pretty good. Okay, now let's add a board to our game. So include board. Let's make it a private member. Board. And we initialize it inside of the constructor. For now, let's give it a position of 200 by 200. A width of, let's make it 10 wide and 20 high. And the cell size, we'll make it, I don't know, maybe 15. We'll try different values and see which one fits better. Okay, now let's go through the whole board and fill it with cells. For now, I'm just using magic numbers all over the place, but we're gonna fix this very soon. Okay, so we can go board dot set cell, and we give it the X and the Y, and we'll give it a color of red for now. Now all we have to do is draw our board. So go board dot draw. And actually, let's make the background a black background. All right, let's hope this works. And we get an error. Okay, what's the issue? What's the problem? Okay, it looks like y is reaching a number it shouldn't reach. Maybe I made a mistake in the loop. Yeah, I did. Okay. Assertions to the rescue. Let's try again. And it seems to be working. I mean, it's kind of ugly, but it seems to be working. Let's make it a bit prettier by giving it a padding. So we gotta add this to the constructor. Int padding. Same here. We initialize the variable. And when we draw our cell, the X position, we want to add the padding to it. We also want to add it to the Y, and we want to remove it from both of these cell sizes minus padding. As you can see, this is starting to get pretty messy. Even if I try to make it prettier by indenting, it's still pretty ugly. We're gonna make this prettier very soon. I know I'm saying soon a lot, but bear with me. Okay, so now in the game constructor, we want to give it a padding, so let's give it a padding of 2. Then let's try again, and voila, this is much prettier now. We are successfully filling our board and displaying it on the screen. Okay, we're making some progress. Except that I don't really like the code we wrote. I mean, look at how many variables we've got in here. And especially this one, it's super ugly. Let's take a look at the overloads for draw rectangle. So here, as you can see, we've got an overload for draw rectangle. It's called draw rectangle V for vector, and it uses 2 vectors for the position and the size. Why didn't we use this one instead? It looks much cleaner. Let's take a closer look at how Raylib defines a vector. So we can use the search function to find it. And there it is, vector2 type. As you can see, it's just 2 floats packed into a single structure. It doesn't seem to bring much value to the table, and it can be pretty cumbersome to work with. For example, if we just wanted to add 2 vectors together into a new vector, we would need to go vector2, vec3, and initialize it with vec1.x plus vec2.x and vec1.y plus vec2.y. Just adding 2 vectors is a huge pain. It would be nice if instead of all of this, we could just go equals vec1 plus vec2, but we can't. This structure is way too simple, it's not worthy of being used in our codebase. To fix our ugliness problem, how about we make our own vector class? So let's go ahead and make a header file. We'll call it vec2. Let's create our vec2 class. And let's make it templated. So we go template, type name t. So we're gonna need 2 variables, tx and ty. Let's make a simple constructor for it. That's gonna take a t for x and a t for y. Unfortunately, for templates, we have to implement in the header file. We can't use a CPP file. So here we'll just go x, and y. If you remember the diagram from last episode, when we declare our own constructor, the compiler is gonna stop generating the default constructor. But in our case, we might need to create an empty vector, so we might need it. So we can just go vec2 parentheses equals default. And now the compiler is gonna keep generating it. Let's make getters and setters. So we're gonna go t get x, which is gonna return x, and it should be const. Same thing for y, and we're gonna go void set x. It goes x equal xn. Same for the y, like this. Okay, now for the interesting part. We're gonna get into operator overloading. So I want our new class to allow us to add, subtract, compare, or do whatever operation on our vectors directly. So let's make our addition operator. So it's gonna return a vector copy. We go operator plus. It's gonna take in a const vec2 reference right hand side. And inside we're just gonna return x plus right hand side dot x and y plus right hand side dot y. Note that we can access the right hand side's private members because we are a vector. Let's do the same for the subtraction. Operator minus const vector to reference right hand side, return x minus right hand side dot x, y minus right hand side dot y. And the same for the multiplications. Let's also implement the plus equals, minus equals, and times equals. So plus equals should return a vector to reference so that we can chain operations. We go operator plus equals, constant vec2 reference, right hand side. So how are we going to implement our plus equals operator? Generally, the plus equals operator is just going to modify the object it's called on. And to save some code, we would also like to reuse the plus operator we used. So how do we use this one? Well, it's going to require a vector on the left-hand side and a vector on the right-hand side. So we have our right-hand side vector, we can just go plus. So we need our left-hand side vector, which is gonna be ourselves. So we can go this, except that this is a pointer. It's not a vector. Our plus operator doesn't work on pointers to vectors. They work on vectors directly. So what we should do is dereference this pointer. Okay, so now we have added our two vectors together. All we have to do is assign them to ourselves. Again, dereference ourselves and go equals. And this is a very nice way of reusing the operator we defined. And also don't forget to return. This is going to return after having assigned it the new value. We should do the same for the minus and times operators. For good measure, let's also implement a comparison operator. So it's going to return a boolean, and it should return x equals right-hand side dot x and y equals right-hand side dot y. And the not equals operator is just the opposite of the equals one, so we can just do this. There is another way of representing the relationship between plus and plus equals. It's a little bit more optimized, but this one is way more understandable. Okay, we can start using our class. So let's go to part.h, include vec2, and our screen positions is gonna become a vec2 of int, screen pause. We can leave the width and height, cell size and padding as they are. But the constructor is gonna take in a vec2 of int for the screen position and a vec2 of int for the width and height. We copy the signature and paste it in the CPP file. So screen pause is gonna receive screen pause. Width is gonna receive width height dot get x, and height is gonna receive width height dot get y. Great. We should also do the same for set cell like this and draw cell. Change them in the implementation. Now we gotta fix up the assertion, so we go pause dot get x, same for the calculation, and get x. We can just use the search and find function to find every y and replace it with pause dot get y. Make sure you have match whole word selected. Actually, it should be get y. And we do the same for the x and replace. Okay, so now all we have to do is fix up our draw triangle. We could make a vec2 of int for the top left position. So first of all, we want to take care of the screen position and the padding, which is the equivalent of going screen x plus padding and screen y plus padding, except that we haven't defined an operator that adds a vector with an integer. So we gotta do that. So here in the plus operator, we can go vec2 operator plus, and it's gonna take in a constant integer right hand side, and it's gonna return x plus right hand side, y plus right hand side. Let's also do the same for the multiplication while we're at it. And it's still not working, because we forgot our const correctness. Operators that do not modify the current vector should be const. For example, the plus operator is making a copy, so this one we should mark it const. Same for this one, pretty much every single one of these except the shorthanded ones that modify the vector and then return a reference to it. And like this. So now we are able to properly add the screen position and the padding. Okay, now all we need to add is the multiplication between the position of the cell and the cell size. Perfect. So now instead of all of this, we can just go top left dot get x and top left dot get y. And this is already becoming much cleaner. And here all we have to do is add curly braces. And this is pretty much the same as going vector2 of int and then creating one on the spot. But the compiler is smart enough to deduce this. So now let's fix our game. So the board now is supposed to take a vector for the position and a vector for the width and the height. And same goes for set cell, takes in a vector, and this should be it. Never mind. Yeah, okay, don't forget your semicolons. That's pretty important. Yeah, same goes for these two. And this one, oh my god. Okay, now it's working. Next time I should really pay attention to my semicolons. Okay, so we have had some nice improvement in our code. But something is still bothering me. I mean, we go through the pain of calculating all of this in one fell swoop, but in the end we're still dividing it into an x component and a y component. Wouldn't it be nice if we could just give drawRectangle our shiny new vector directly? Unfortunately, all of Raylib's functions are using this super dumb vector2 class. So this is a problem. How are we going to make it compatible with our new vector2? Well, we're gonna make our own wrapper for the Raylib library. This wrapper is gonna be responsible for making Raylib's functions compatible with our new classes. So let's make a header file, call it Raylib CPP. So we're gonna need to include Raylib because we're gonna wrap it. And let's make our own namespace. We'll call it Ray CPP. We'll make it lowercase. We want to make our own overload of the drawRectangle function. So let's go inside of Raylib, search for drawRectangle. Let's copy its signature, just to make it a little bit easier for us. Okay, so let's include vector2, and instead of taking position x and position y, we're going to take in a vector2 of ints for the position, and a vector2 of ints for the width and the height. And we're going to keep the color the same. So for the implementation, we make a CPP file, we include Raylib cpp.h, and we implement our function. And inside, we're just going to call drawRectangle, and we're going to give it position.getX, position.getY, width.getX, width.getY, and the color. Oops. And this is pretty much what a wrapper does. It takes in new parameters and then dispatches them into the old version of the function. So now let's go to our board, and where we included Raylib, we're gonna instead include Raylib CPP. And inside here, instead of calling drawRectangle, we're gonna call Ray CPP drawRectangle, and we can directly give it the top left. Here we create a vector2 in place. Note that if we were not using C++17, we would have to write the int template here. But since C++17, the compiler is able to deduce the template type automatically, so we can omit it. Oh, and of course we forgot to do a minus version for the integer. So we go vector2 operator minus const int right hand side, mark it const, return x minus right hand side, y minus right hand side. Very nice. As you can see, this is much cleaner. We went from an absolute mess to this beautiful code right here. While we're at it, let's include assert and check that we are not trying to draw outside of the screen, because it's not something we would ever want to do. So let's go assert position.getX is bigger or equals to 0, and position.getY is bigger or equal to 0, and position.getX is smaller than getScreenWidth, which is a Raylib function that returns the current width of the screen. And we do the same for the y. And there we go. Not only we are wrapping our functions to make them compatible with our new fancy tools, we are also making them safer. And that is pretty much it for this video. Next video, we're probably gonna make this look a bit better, and maybe we'll start working on our tetrominos, inshallah. Until then, thank you for watching, take care, and see you soon. Oh, and also use the comment section and like the video, and you know the drill. Thank you.